together. And if you haven't already, please sign into your calculators. One thing that we are going to do for you all, some of the other, in years past, and we have one unit after this one. This is our last unit on this. Yeah, I think so what we did was, your other classes in past years, you may have had to buy a green book. Is that what happened before, buy a review book? So this, in lieu of that, we're giving you, there's only been 3 exams that have been given, but we bound them all and put them together. So at some point coming up soon, we are going to have these going out. And I actually think, instead of going into our last unit, we may take a little bit of time to ease in to it, because there's really only one type of question that last unit is going to ask that you don't know how to answer. We may start reviewing a little bit early and then mix in one more unit and then go into the home stretch for good. But understand, you'll be getting a book like this. Any supplementals you want, and trust me, you think I go through paper now, you should see. I'll have tons of stuff for you to go through. These are the actual exams, nothing changed. We'll be handing those out to you all at some point, maybe even today. The onus, though, is on you to make sure, number one, you keep them, because you're not getting the second one once you get your first. And if that means you're writing things out by hand, so do it. And make sure, please, some of us, I don't know what happens when you go home, is if there's some sort of paper shredder, or like your parents are emptying the garbage disposal into your book bags every night, and pouring some water on top of that, and then making it all get together, form some sort of disgusting soup in your book bags. Whatever it is, let's try to keep them in relatively good shape. And for those of you who really want extra practice, the textbook company sends it wants to get addicted to using their stuff. They send us a bunch of workbooks. Whoever wants an extra workbook of this individual review, there's like an example and then 40 questions like the example. Whatever it ends up being, I hope, though, that you all understand, in terms of review, it's going to be very, very challenging, because I have such profoundly high expectations for you. So my hope is not only that you will do well, but that you're going to be, I want them to look at you and send the authorities over here. If they see the exam beforehand, how is it possible that a third of your students got perfect papers? Well, no, we didn't cheat. We just worked very, very hard. That's our goal. And even then, you don't have to, like they said, a third of your kids got hundreds, okay, only a third. So that's the expectations of for all of you. And frankly, to be honest, I can't wait. I really, really can't wait. It's like doing, it's like they say, like making chocolate chip cookies. So as of now, I have all of the ingredients, and they're sitting on the counter. And then soon we're going to make the cookies. And then the best part is we're going to put you in the oven on, what's the day that the exam is? Did I mention what the day is or no? It'll be sometime in June. I think it's towards the beginning, particularly that Friday of the first week that you have it. And then you're going to come out of the oven and there's going to be this delicious cookie, and you're going to spreadsheet with your grades. And I'm going to tell you exactly how well you did. And I hope every one of you is a perfect chocolate chip cookie. Every one of you. Because you will be made of ingredients by me. So, I'm lucky. You wake up every day, I'm so lucky. I get to see that crazy old lady every day. Every day. Blessed. Blessed. Now, when I see that first question, what do I see on here? What do I want to handle? Caleb, how would I figure out the common ratio? By the way, when you see common ratio, let me change the question. When you see common ratio, what does that make you think of? What are common ratios associated with?
Like it's the second term divided by the previous term.
Yeah, we would know that it's the second term divided by the first. That's how we find it. What umbrella category does that fall under? Do you recall? What are they used with? Hands up if you can answer that, please. What is a common ratio associated with? Yeah, this is going to be one that's geometric. Now, so when we do this, you wanted to find your R, Caleb, by dividing what by what? You get to pick.
I think of 3 over 32, 8 of 3 4.
you're going to divide that by what?
1/64.
Now, the reason, by the way, some people in the other sections are going, we need to do it multiple times. I'm going to argue you don't. It's telling you it's geometric already, so it's already, we know that it's going to be geometric. You're not having to prove it. Looking at what's there, let's ask this. There's fractions to reduce A's and B's. So, Sam, which one would you like to reduce? You want to reduce the fractions on top of the fractions, the A over A or the B over B. Which one? You get to pick. Okay? So what is going to be left when you reduce the A's, and is it going to be in the numerator or denominator? Outstanding. Next one up, Lily, what do you want to do, the fraction or the B's? Okay? What is this fraction over this fraction going to reduce to and where? Now, she said it over 1, and that's very good. Because some people say it's -6 and maybe it's in the denominator. We don't know. You absolutely do know. It's -6, that is the fraction, -6 over 1. We've got one last part to look at, and Stephen, what's left after you reduce the B's and where? There you go. So you'd have something like this. Now, if I were tidying it up and trying to make it look perfect, I'd get rid of the 1 that's implied. That's what your common ratio is. Questions on that? What?
What if we moved the a squared to be a negative a squared?
You wouldn't leave that because you don't want a negative x value. Next one up, take a look, please. And Eva, what would you go through and do in order to get an answer for the next question? I'm going to tell you, by the way, you don't need your calculator. Go ahead. 27 to the 4/3 is equal to 2x minus 1. Now, we've got two things that we're going to deal with, especially if we take the calculator away from you. You could obviously type that in on the region, and it's fine. There's a 4/3 is the exponent. What do the halves of that represent? Hands up, please, if you can tell me. That 4/3 is a power. Go ahead, please. So that's your root, and what's the 4 represent? Yeah, power. So it goes power over root. Looking at that, now, you don't need a calculator. Which one of these would you handle first if you were to do it out in your head? You want to raise 27 to the 4th power in your head, or you want to take the 3rd root of it? Angel, which one would you say? Okay, what's the 3rd root of 27? And then take 3 and raise that now to the 4th power. What's that going to give you? Great. So we've got 81 is equal to 2x minus 1. Can you keep going, or are you tired? Okay, what are you going to do now? We got 82 is equal to 2x, and from here? Now, what's that going to be? 82 divided by 2? 41. Now, we always need to go back and check. You can always do an end solve on this. No matter what the algebra tells you, you've got to make sure that the answer that you're putting in does not cause the argument here to be negative. Keep that in mind. You could do an end solve on this to check, and obviously it will check. Last one up, we need to solve algebraically. So, Angela, what would your first, actually, Angela, sorry, how many answers, Angela, will this equation have? 4. You've got to remember that. Be on the lookout for 4 answers. If that means you write 4 answers next to it in the beginning, so be it. Jordan, what's your first step going to be?
I would add 16x to both sides.
So we've got x to the 4th plus 4x to the 3rd plus 4x squared plus 16x is going to equal 0. What do we do now to solve this out? Jocko, you tell me.
So, I grouped the factor by grouping.
Okay, so what do you got? What did you look at the first two and look at the second two? What's the GCF of your first two?
It was factor out x cubed
Okay,
plus x
okay.
plus 4x.
Okay, so far he's absolutely right. We did a GCF once. Looking at what's there, and this is the part where some of you don't see it, and it gets a little frustrating. This is nothing more than an awkward binomial. Binomial is 2 halves, or an expression that's separated with an addition or subtraction sign. So there's 2 halves on this. There's a left half and a right half. The addition sign is the separator. looking at this, what type of factoring can we do on this now? I said what type of factoring, so it's not going to be a number, it's going to be a word. Give it a try. Yeah, what's the greatest common factor from both halves of this that you can factor out? And what's left when you take that x plus 4 out from both sides? Now, I'm still not done factoring this down. Hands up, please, if you can tell me why I'm still not done factoring this down. And some of you might have done this step in a different order. Looking at what's there, Cece, what can you still do? There you go. So there's an x out front, single terms, and then our binomials. So far, as of now, this cannot be factored any further. Looking at what's there. Okay. Looking at what's there, Felix, what's your next step going to be? What's the them? What are they called? There you go. Set each one of my factors to be equal to 0. Now, looking at what we have here, I've got one that's already solved. You've got one of the 4 answers immediately. Which one, Jake, do you want to solve going forward from here? And what do you do to solve that? Subtract the 4 over x is equal to a negative 4. This is the one that always gets awkward because there's about 20 to 30% of you that want to factor this. This will not factor. Hands up, please, when you can tell me why this won't factor. Why this won't factor.
Because if you do x plus 2 times x plus 2, then it'll add up to having like 4x.
In the middle.
And you'd have to subtract the 4 and then
now you're getting into the solving. This is not a difference of perfect squares, and the easiest way I can explain it to you is this. Difference is what math operation? Hands up when you can answer that. What math operation are we talking about when we're saying the difference of perfect square values? We got 5 people. Seriously, this is a 7th grade question. Go ahead. Subtraction. Is there subtraction between 2 perfect squares? Is there? No. This is a sum between squares. So, does that factor down? No. How would we go about solving this out? Olivia, what would you do? So what am I right now? And what do you do from here? And what are you going to get for your answer? X equals plus or minus what? No. No.
Oh, 2i.
Thank you. Now, I don't know if have I shown you polyroots yet or not?
Yeah.
Go into your calculators then, all of us. Now, that doesn't mean some, that means all. You're going to go into your calculator, and I believe that it's under Algebra. Go into Algebra. On a new screen, go into Algebra. There should be an option that says Polynomial Tools. Is that what it's called? Select that. Go down to the one that says See Polynomial Tools. And you're going to always want to pick that one because it gives answers that are either real or complex. And when you're looking at this, what you're going to go through and do is type in the expression that this would convert to, which is this right here. Everything's set equal to 0 except you don't write the equal 0. So put in the expression. Put in the expression. And then do comma x and press enter. No equal sign there, no bars, no nothing. The poly expression comma x. And what do you get from that? Hands up, please, when you can tell me. What do you get when you type in? We got 2 people. Oh, get real. Get real. What? Does that confirm or dispute what we said the zeros of this graph or solutions to the equation are going to be? Confirm it. And if you forgot the plus or minus 2i before, you better get it right now. Go ahead.
Where is it?
When you go under, press Algebra, or hit Menu, go to Algebra. And then there's Polynomial Tools. I think it's the second or third one down. Is that right? Then select that and go down to See Polynomial Roots or something like that.
It's called
Complex. Okay. Okay. However you get there, it's fine. that's a tool that's available to you. Now, understand, we left off last time on page 16. Now, when we do this in the beginning, we're going to do some computations that require you, and let's get our notes out, let's make sure we're good to go. We're going to do some stuff that requires us to, some of us do this when we raise our hands again. We're not giving a sidearm high five. If you were to raise, yeah, not like that at all. It's this, like you get nice and high, okay? Let's everybody right now pretend that there was $100 bill dangling from the ceiling right now, and you're going to reach up to try to get it. Let's all do that collectively right now. And that's nice. You got that much money, Angel? Please. Nice and hot, as in extend. We don't want a bent elbow. Nice and hot. We're not checking for deodorant. If you need some, we have some spray deodorant you can use. Now, when we do our surveys here, all right, you can set them down. When I ask us to go through, I'm going to say, we'll give you this amount of time. If your hand is not up, that means your shoulders are down, your arms are at or around the waist. If your hand is up, it means go like this, nice and high in the affirmative, that you are raising your hand. Because I can assure you, nothing is more irritating than trying to take a poll of you all, and then people are going, wait, what one? Oh, is it not this? Stop it. We're trying to get to add. You go like this or not like this. There's not an image, it's not this. This isn't half, okay? Now, we're going to go through and let's do a quick, actually, this is really easy. 1, 2, 3, 4, 5, 6. So that means as of now, there's 22 of us in here. Okay. Now, looking at this, raise your hand in the affirmative if your favorite color is blue. We're going to give you 10 seconds to choose. Lock in your choices. If your favorite color is blue, nice and high. After, okay, as of now, no more hand raising. Sorry, don't raise your hand. Whose favorite color is blue, nice and high? Those people are locked in. Hang on, I need to do a count. We got 1, 2, 3, 4, 5, 6, 7. So, out of our class, probability that the favorite color is blue is going to be 7 out of 22. And we need to make sure that we stay quiet when these are done, because the question itself, you're going to miss if there's too much talking, because people need to get attention that they're not getting. Out of our class, the probability that a female is selected. Now, let's do this. Instead of me doing it, we're going to give you 30 seconds. There's 22 total in the room now. I want you to look around. You see each other for the first time. Hands up. Hands up, please. You can tell me the probability of selecting a female from those in the room. You're not talking in any way. It's literally turning your head around. Hands up when you can tell me the probability of selecting a female in our room. Look around. Say. Hands up. The affirmative. And we can go through and state probability of picking a female from the room. What do you say, please? Okay. 10 out of 22. Now, and by the way, I don't know if we did this. I think we did before. You'd say something like this, probability that the person's a female. That's the correct notation. Yeah, should do something. No, and that's another thing that comes up in this unit. The calculator can simplify. If you need to go through and on an exam or something simplify, that's fine. I like to keep the original because if I'm looking at this, I look at it and say, all right, looking at that right away, I know that there are 10 girls out of 22 total people. That's why I don't like doing the reducing. You can, on the reads, you could go through and do the reducing. That's why I don't do it in this unit. Next one up. If a person chosen is female, what's the probability that her favorite color is blue? Now, what that means is there is an initial condition set forth. If the person chosen is female, what's the probability that their favorite color is blue? Hands up, please, when you can answer the. Oh, wait a minute. Raise your hand, please. Those of you who said your favorite color was blue. Raise your hand, those who said your favorite color was blue. Nice and high. Look around the room. Nice and high. Look around the room. Hands up, please, when you can answer question C. All of you can put your hands down now. This is the answer for C. You're volunteering. We've got 1, 2, 3, 4, 5, 6, 7, 8 of us. What would you like to say? You said 1 out of 10. This means that there's one person that's blue out of the condition of having 10 females. Questions on that? The second question is not to be a wordsmith on it, but to get you to understand the difference and the importance of the language that you use. The second question says, out of the people whose favorite color is blue, what's the probability that that person is female? So, out of the people who say their favorite color is blue, what's the probability that that person is female? What would you like to say? Notice they are different. You have to look and say, are these things happening in tandem with each other, or are they paired together? Or is one happening after another is happening? Because the way that you approach the questions will be quite different. If something given something is a condition, then you're going to approach it differently than looking at the whole group. Because there's going to be questions today that put modifiers on. So you have to meet the first condition in order to meet the second one. Now, looking at this, that's called conditional probability, and the notation is this. This bar in the middle reads given. So the probability of B given A means which one has to occur first. Hands up, please, when you can answer that. If it's probability of B given A, which one of those would need to occur first? Jordan? A has to occur first. Out of A, you are taking the probability of B happening. Out of A, you are taking the probability of B happening. The way to compute out B given A is to go through and evaluate the probability of B and A both happening over the probability of just A happening. Remember, A is the initial restriction, and then B is happening out of that restricted pool. Okay. And again, it would be similar to, what's the probability of me getting a girl in this class? Well, how many girls did we say there were? 7? Is that right? 7 out of 22? 10 out of 22? Sorry, 7 was the blue, right? Okay, so as of right now, the probability of that would be, what did you say, 10 out of 22? Now, what's the probability of getting a girl given we're in the first row? That's going to be quite different. How many people am I drawing from? The first row. Probability of getting a girl out of the first row then would be 4 out of 5. Now, looking at what we have, something, then something. We've got, these are called two-way tables, and hopefully we can burn through this. Oh, one other thing, just so you know. Bring with you, and I don't know how long this will take me. I have to go through, and I have a meeting over at Thomas tomorrow. It's scheduled for 1:15. I'm actually going to get there even earlier than that. Mr. Crinzy is going to be here to start. And I'll be coming in. Hopefully, the meeting starts at 1:15 and should take no more, I was told, no more than 20 minutes, and then I have to come over back here. So my goal is for miss less than 5 minutes. But in any case, I'll be here, be coming back, etc. So bring with you your computer books next time. We'll start off you will find the video, and I'll make sure to post it. Make sure, please, that you have that to start. I don't know how long it will be. Some of you, I'm sure, are probably hoping that either my car dies or I get knocked off the side of the bridge crossing 104 or something horrific on the way there. And I can assure you, that's true. That's true. But the other end of it, yeah, you're right. You still have to suffer through the rest. And you know what'll happen? I'll come back through beyond the grave. Don't you worry. Even if something happens to me, you'll hate it because actually, I found out there's a thing called Google Hangout that we had a meeting on. So I'll even make all of you get on your computer still, and we'll have just one big giant fest and yelling at you from whatever hospital. And then, like, it keeps back together. And if I don't have a head, I'll still find a way. I'll find a way. I'll make Siri do it. I'll type into Siri and tell her what to say. Now, looking at what we have, first one up, we need to find the probability that someone likes a comedy given they're in that age group. So, I always like to break it down like this. Let's do the probability, and this breaks down to the probability of the comedy and being 26 to 49 over the probability of, or the number of 26 to 49. So to start this, what's the numerator going to be? How many meet both conditions? Hands up when you can answer that for us. How many of us meet both conditions? We can construct this numerator. I love. You guys are such a bunch of babies. Call the ambulance on you. What'd you say? Out of what? Take a look at the second group. Have it. Now, the next question is, what's the probability that someone is over 50 given they like horror movies? How would I go about computing that? Well, I would first need to start and say it's the probability that someone likes or is over 50 and likes horror over what in the denominator? Not a number, Teresa, but what would we have in the denominator? There you go, the number of people who like horror movies. So looking at this, what would our numerator be? I don't need you to reduce. Excuse me, Ben, what's your numerator? Over? No? Hands up, please, when you can tell me your denominator on this. What? 680. Terrific. Questions on that one? Now I'm going to snake over to the other side. I need to determine the probability that someone likes horror movies given that they're over 50. So looking at that, I need to take the probability of horror and over 50 and divide that by the number of people who are over 50. Hands up, please, when you can tell me what your answer is here. I don't need it reduced. We've got 1, 2 of us. Aaron, what do you think? Hands up, please, if you can tell me how those are different. Because, boy, looking at this, if I'm a simpleton, I look at B and C and I go, that's saying the same thing. How is B and C, B and C different? Mm-hmm. So that initial screening that's done is different. You're drawing from everyone who likes horror to determine who's over 50 versus everyone who's over 50 determining who likes horror. They're different things. Now, I want you to read question D right now, and I want you to give me a fact-based or evidence-based answer for it. Something that would hold up in court. What? That would be the youngest grouping of adults, let's say. Who's got a fact-based answer with a nice big adult sentence? An adult doesn't mean you're swearing in it. Let's give a nice, regular, common English, a sentence Miss Capolo would be proud to see you use. We've got 3 people who can answer the question. Come on, do some analysis on this. Olivia, what do you want to say? Why?
Out of the 3 categories,
I want to talk, I guess you would, well, I'll say this. It's possible for him to have the most, but not, well, I guess I'll come back to why I don't like that in just a second. Michael?
Comedy because it has the highest ratio of young adults.
There's one word I want us to get to. Yeah. We're not saying the math term in there.
Comedy because it has the highest probability
There you go.
of young adults enjoying the comedy.
And it's possible for like a genre to be very popular and have the most numbers, but if you're dividing by something else, I want us to make sure that we're talking about the probability, because it's possible, like if I were to go through and say, yeah, 1,000 people out of 2,000 like this type of ice cream, so it's the most popular. But then someone goes, well, wait a minute, I did a survey and 9 out of 10 liked it. So which one has the higher probability? 9 out of 10 versus 1,000 out of 2,000. Okay? There was another answer that was said, and I didn't mean to cut it off, but I just need you to make sure that you're giving that in terms of probability. Okay? So state something mathematically there, probability. Now, granted, on the Reach, they'd probably take every single one of those answers. Take a look at E. And hands up when you can give me an answer for E. Especially knowing what we know now. Maddie?
You should choose order because four has the least probability of
It has the least probability of being, oh God, this is going to be awkward if I take this right. It's going to have the least probability of being seen or liked from that age range. You always have to qualify it, okay? Questions on that? All right, now we're going to look at the next one. When you do these questions, when we're talking about probabilities, I need you all to understand. First of all, always take a good look at the table, look at it and understand what's going on before you rush to a question. That's number one. And number two, you constantly need to be asking yourself, is this conditional or is it a single event? Meaning, is it open to everyone or did we restrict it down in the start? Does something need to happen before this event can happen, or is it just the probability of the event happening in and of itself? Looking at that, before I get started, who can tell me what you think I'd want to do before I answer any of these questions? Read what's there, and hands up please if you can tell me what you'd probably want to do before you got started on any of these. There's something I always personally like to do whenever I see a chart like this. That's not on this chart. It will be given to you on some. Jordan?
Add up the total number.
Yeah, let's figure out the total number, and hands up please when you can tell me the total number of participants in this acne cream survey. Hands up please when you can tell me the total number of participants. Caleb, what do you want to say?
Thank you.
Terrific. So over to the side, I go through and list out that I know that there are 1,900. Notice I did the same thing before I started our probabilities in the beginning. I counted up how many of us there were in the room to start. Now, looking at this, it says if a person used the cream, what's the probability that the person's skin improved? Now, is this a independent event or is it dependent? Hands up, please, when you can tell me. Is it independent or is it dependent? We got one person who can answer. Two, three, who's going to say? It's dependent because when I'm doing this, something has to happen first before my condition happens. So it says if a person used the cream, what's the probability that they improve? So what has to happen first? They have to use the cream, and then we see out of that group how many have improved. So when I do this, I like to list out little letters on the side so I can do this shorter. This would be, let's say, the number that improved going across, and then this N will be for not improved. Then going down, this will be like a C for use the cream, and then this going down would be a P for use the placebo. Questions on that? Now, let's look at the setup. Who's got an idea as to what the setup on this is going to be? It's going to be what given what based off of what you all told me. Look at what's there. It's going to be what given what based off of what you told me. We've got 1, 2 of us. What has to happen given something else? Given, no, not and, it's given. There you go. What she told us right now is, I'm determining the probability that they improve given they use the cream. That's different than saying the probability or the number of people that improved and used the cream. Do you understand what I'm saying? Okay. So looking at this, now we're going to set this up by taking the probability of I and C over the probability of C. Looking at this, hands up please when you can tell me what the answer to this would become. I don't need it simplified. We've got 3 people. Maddie, what would you say? What is this going to work out to be? There you go, bud. What's the number that we have in that used or that had improvement and used the cream? How many is that? Over? No. Who can tell me what that denominator is going to be, Ben? 1,100. How many did we have that used the cream? Just go down. Next one up. Out of the people who saw no improvement, what's the probability that they used the acne cream? So when I look at this, out of the people that saw no improvement, what's the probability that they used the cream? Is this a straight up probability or is it something given something? Is it a conditional probability? We've got one who can answer this. Is this a generic probability or is it conditional? Looking at what we have, Logan, what do you think? What's that? Yeah, so what would you write it out as? Probability of what given what?
The probability of using the cream.
Okay. Given.
Improvement given they use the cream.
So I'm sorry, you said the probability of what then?
Improvement given they use the cream.
Careful. Who's got one change that they want to make to that, if I remember right? There's a change we need to make to this. Because you've got to look, what's the group you're pulling from? Because that's going to be the group that goes second. What do you say? What's that? So we need, so you're saying just change this? So looking at this, does anybody see this differently? And it has to do with the reading of it. Jacqueline, what do you want to say? Why?
Because it's the probability that someone that had no improvement also used the cream.
There you go. What's the initial filter on that? What's the initial group you're pulling from? Because you're not pulling everywhere. What's the first criteria it has to meet? No improvement. So that's the one that goes second. So imagine all of you are here already. Go, all right, now everybody who had no improvement, you're going over to Miss McGee's room. So all of you, so that's the first filter that's on. And then when I get in there, I go, all right, all of you are in here, have had no improvement. How many of you have used the cream? So you've got to really play it out. And this is the part where, and I'll tell you right now, as a person who hates reading, I go through and I took Providence Stats 1. Not 2, not 3, not 4. I stopped at 1. Why? I hate the reading. You all have to be readers, though, of it, and critical consumers of what's there. Looking at this, I go through and say, well, I need the probability of cream and no improvement over the number of no improvements. Go through right now, loves, and compute that out. Hands up, please, when you can tell me what that's going to be. We've got 1, 2 of us. Seriously? Seriously? 3, 4. Lily, what do you want to say? Terrific. What's the probability that someone used a placebo and their skin improved? Now, is this conditional probability? Yes or no? Michael, what do you say?
No.
No. You just need to look for the probability that they used a placebo. So we need a probability that they used a placebo and their skin improved. So how many is that going to be?
600 out of 1900.
There you go. What's the probability that a person used a placebo, or sorry, what's the probability that a person who's used a placebo saw improvement? Is this straight up or is this conditional? Hands up, please, when you can answer that. Is this regular probability or is it going to be conditional? Which one? Mike, what do you think? Conditional. Looking at what's there, Mike, what do you think this needs to be? Set up the conditional statement then. What given what? Okay, so you're saying seeing improvement given they use the placebo, is that right? That says it's a probability they had improvement given they used the placebo. What?
I have a question on C.
And hang on, please. Who can help us with this setup? Yeah. Yeah, because what's the first filter that's on there? What's the probability that a person who used a placebo saw improvement in their skin? So when we go through and look at that, you need to make sure what's the first thing that needs to happen. Who are you telling to go to the other room out of everyone? Felix? The people that use the placebo, and then out of that group, we need to figure out who saw improvement. So it's improvement given placebo. That would be the probability of improvement and placebo all over the probability of placebo. Go through and compute that out right now, and then Olivia will answer your question. What is this going to simplify out to be? And Spencer, let us know what you get when you get it. No? 600 out of 800. So where do I and P cross, the number that we had to use the placebo and had no improvement? That's 600 out of a total amount of number that used the placebo. That would be both of these 800. Go ahead. What's your question?
How would it be out of 1900?
Who can answer why? Question C on here is out of 1900. The other ones we've worked with so far didn't have division by 1900. Why is this out of 1900? We've got 1, 2, 3 of us that can answer. That's it. 4. Caleb, why do you think this one's out of 1900 as opposed to some other denominator?
1900 is the total number of everyone in the chart. So those who use the cream is 1100 plus those who use the placebo.
Mhm. Right. What you're doing in that second case, you're not putting an initial grouping on it. You're saying, all right, who are these people together? Everyone in the same room, raise your hand. We're not saying what's the probability of it given something else has already happened. We're saying what's the probability of this happening? Everyone's in the same room, raise your hand if this is you.
Okay, that's yeah.
Yes. And it's a probability of both of those things happening from the whole group. There's no initial exclusion to narrow it down and then pull from that narrowed group. Yes, Felix? No, the order doesn't matter for the and symbol. Doesn't matter if there's an or there either. It definitely does matter, though, in the other one. You've got to take into account. Think of it this way. Put yourself in these person's shoes. If I'm pulling from everyone in here and I'm trying to answer this question, it says, out of the people who saw no improvement in their skin, what's the probability they use a cream? If I'm doing that with all of you as my subset, you're my 1900 people, I'm not just asking you to do it now. I literally am saying, well, you tell me, in question B, who am I pulling out in order into the second room to get my probability? Who am I getting to leave the room so I can go through and count them in another space? The people who saw no improvement. And now once all of you non-improvers are in another room, I then go through and say, all right, how many of you that didn't improve, how many went through and used the cream? Am I taking it from everyone? No. I'm only looking at people who meet both conditions, and the second condition has to be met after the first is met. So it really does narrow it down. They're quite different things. It's a difficult concept to get a hold of. Now, let's look at, and I want to make sure how much time, I hate how long we go. All right, go through right now, please. We got to it in the other groups. Go through right now, please, and circle page 18, 19, and 20. That's going to be what you've got for homework tonight. We're going to start off with day 4, because I think we can get some of day 4 done, and then tomorrow we can catch up and get everything done. Go over, please, to page 21. You all should be familiar with the tree diagram. A tree diagram just maps out your outcomes. First one up says draw a tree diagram that represents a coin being tossed twice, include the probability. So when you flip a coin, hands up please, and tell me how many outcomes you have. When you flip a coin, how many outcomes do we have? Well, 2. There's heads or tails. So I go through and probability. First one, should be heads or tails. And then once you get heads the first time, it doesn't change the probability the second time around. Now, and we're going to affix the probability. The probability of getting heads is 1/2. So is the probability of getting tails. If you get heads the first time, the probability doesn't change the second time. We were talking in the other section about how I have a friend that in their family they have 8 girls. 8. Why did they have 8 girls? Because the dad kept convincing the mom, let's try one more time because I want a son. And they go, we've had all these girls. Obviously, we're going to be more than likely to get a boy the next time because we've had 4 girls. Does biology care what happened before? No. It's not like before the gender of the baby is biologically decided, that single cell in the uterus pops out and goes, hang on just a second, you got 1, 2, 3, 4 girls here? All right, I'll be a boy this time. Does that happen? No. Now, next one up. An auto insurance industry charges. Now, this one is very interesting. And this is actually, these are true statistics. You should know, the younger you are, the more you pay for insurance, and this will be why. Auto insurance company charges younger drivers a higher premium than it does older drivers because you all tend to have more accidents. Because, by and large, you're terrible drivers. Looking at what happens out of Group A, we've got 3 initial groups, Group A, Group B, and Group C. Group A is 22% of policyholders, Group B is 43%, and then Group C is everyone older. So I'm going to do it on a separate page. You're making your initial filter or initial branch. How many choices do we have? And the answer would be 3. You've got Group A, Group B, and Group C. Now, what probability do we have of getting someone from Group A out of the total pool? Go ahead. 22. Group B is going to be what? What did you say? 0.43. And everything else, I think it's 0.35. Now, after we made that branch, how many choices are we going to have after A? Hands up, please, and tell me how many choices we're going to have after A. Yeah? What are they? So, you've got these as outcomes, and that's the case for each one of these. Now, what's the probability that you have an accident and if you're in Group A, how many of those people have an accident over the course of the year? Yeah. What's that? 11%, which means no accident would be 89%. You're in group B. What's the probability that you have an accident? Go ahead. 0.03, which means 97% don't. And then in group C, isn't it 0.2? 2%, right? So that means this would be 0.98. Now, make sure you come ready to go next time. Make sure you got your Chromebooks and your headphones. I should be back quickly, but we're going to have a ton to burn through, a ton. Next time we meet, I'll post a video in Google Classroom before I leave. I'll be in the whole day. I just have a quick meeting at Thomas that I have to go to at 1:15. Yeah, thank you. I know. I'm going to run now. Make sure, Lux, you put your stuff in over on the side. Take my time. What, are you kidding me? This is where I want to be.
I'm outraged and offended that you love that document.
Mr. Math,
Yes.
can I ask